Okay, so you had an idea right in the beginning. And what are we trying to count here? In the original problem.
So
what are we trying to count?
The original problem, we want to count the number of cases that have none the same.
Number of cases that have none the same. Okay, and what was your plan on how to try to count this?
So I wanted to count the number of cases that had one or more the same.
One or more the same. Okay.
And then subtract that away from 24, which would leave us with the number of cases that had none the same.
Alright, so count the cases that have one or more the same, and subtract that away from 24. Why are we subtracting away from 24?
Because that's our total number of cases.
Okay, so we're going to do 24, total number of cases, minus something here. Okay?
Yeah.
So how are you going to count the ones that have one or more the same?
Well, we can start by counting the number, we can look at our 4 cases that have one the same.
Okay.
So it's with these, and for each of these cases there's 6.
Alright.
6 things in each of these cases.
Okay.
3 choices, 2 choices, 1 choice.
Okay. So we have then 4 cases times 6.
It's 24 cases.
Okay, so we start out by 24. Now we have 24 minus 24.
So we
What's happened here?
Well, we subtracted all of these cases away.
All right, and
But the only problem is that we didn't count all the cases. Like in these 4 cases do not give you all of the possible arrangements of these.
all right. So show me one that it doesn't give.
So it doesn't give that.
Okay. So this was all the cases. We just subtracted away something, and we noticed we're at 0 right now.
Yeah.
This is a new case.
But we never subtracted this case away, so what must have happened?
So we subtracted away some cases more than once.
So we subtracted away some cases more than once. So what do we need to do?
to add back in a few.
Add them back. Okay.
So I think we subtracted away the cases that we subtracted away the cases that had 2 the same more than once.
Okay. How many cases are there with 2 the same?
There's 6 of them.
Okay. How do you know that?
Because there's 4 things and you can choose 2 of them to be the same.
Okay.
To stay the same.
All right. So we have 6 cases where we have 2 the same, and how many are there in each one of those cases?
Then there's 2 in each of those cases.
Okay. So we're going to take those and subtract them away from here. So it's 6 times 2. Okay, so now we've got 24 minus 12 in here.
Yeah.
So now we have a lower number we're subtracting away from 24.
Yeah.
Okay. Is this all the cases?
No, because subtracting these away, we again overcounted the one case that has 4.
All right.
Because
Here.
Okay. So how many times did we count that case here?
So we counted that case 4 times.
4 times. We've subtracted it away.
6 times.
Okay.
But we only need it once.
All right. So how many of those do we have to put back?
So we need to put back 3 of those.
Put back 3 of them. Okay. Do you see that?
Yes.
Okay. So we now have 24 minus 12 plus 3. So that is 24 minus 12 is
It's 12 plus 3 is 15.
15.
Yeah.
And what's 24 minus 15?
9, like
9.
we thought.
Like we thought.
So there are going to be 15 cases that work for the problem.
There are going to be 15 cases that work for the problem. So this is a really nice solution, guys. So we got to the end of this problem. And I'm going to just show you very quickly one just slightly more complicated problem with 5.
Okay.
Okay.